Vanakkam one and all. In the second problem of exercise 5.1, we will examine the continuity of the function where f of x is equal to 2x square minus 1 at x equal to 3. Okay, so for this function we can say it is continuous on entire real numbers because it is a polynomial function. Since it is a polynomial function, it is continuous on entire real number. But still, they are asking us to check the continuity of the function at x equal to 3. So, to say a function is continuous at a given point, then that should satisfy this condition. Limit x tends to a, where a is the fixed point, and f of x is equal to f of a. In this case, we can say the function is continuous at a. So we are taking x as 3. So we can calculate the functional value. So what is that f of 3? Functional, by replacing x as 3 over the function, we will get functional value. So 2 into x square is 3 square minus 1, which is 3 square is 9. I'll write it in detail. 18 minus 1, which is 17. So 17 is the functional value at x equal to 3. Now we will calculate its limit. So limit x tends to 3 to x square minus 1. So for this, 2 into 3 square minus 1, which is equal to 17 again. So here the functional value is equal to limit of the function at x equal to 3, which implies it says the function is continuous at x equal to 3. Okay, even without this explanation, as soon as we see the question, we can decide the function as continuous at any real number. But still they are asking us to examine the continuity. We have proceeded this explanation. We have applied the definition to get the solution. So we will discuss the third problem now. Now it's third problem for subdivision. So here we are given f of x is equal to x minus 5 and we have to check the continuity of the function. So again, the given function is nothing but a linear polynomial, isn't it? So polynomial is a continuous function on a real number. So for any real number, we can say the value exists. The value is definite. So we can say the function is continuous for any real number. See, which means we can't find a real number which gives not definite value. Even for any input, but don't think about infinity. Infinity is not at all a real number. Okay, so if you replace x as any real number, you will be able to get one definite value, one particular quantity, one particular number, so that we can say the function is continuous. The value exists for any real number. Okay, so let us take a real number k. Let k be any real number. We will apply the definition of continuity for this real number. So now, to say the function is continuous at the point k, where k is any real number, that should satisfy this definition. Limit x tends to k, f of x is equal to f of k. Yes. So what about the functional value now? F of k is equal to functional value f of k is equal to k minus 5. Now we will calculate its limit. So limit x tends to k x minus 5. Again, when we substitute k as 5, we can substitute k as 5. So when we substitute k as 5, we'll get, sorry, x as k, we'll get k minus 5. So here both functional value is equal to limit of the function as x tends to k is same. So we can say the function is continuous, which implies f of x is continuous. Okay, so we will do the second subdivision now. Again, in problem number 3, second subdivision, we are given a function f of x is equal to 1 by x minus 5, where x is not equal to 5. What if x is equal to 5? If x is equal to 5 means which is not defined. So the function is not defined at 5. So they have given the domain of the function as real number set, which is excluding 5. Okay, so we will consider any real number apart from this 5. Now we are going to consider a real number. So we can say f of x is continuous. Okay, is continuous for all real numbers. So let us take continuous. Let us take at k. K is some real number. So what about the functional value? 1 by k minus 5. It's a functional value. Now let's calculate limit of the functions. So limit x tends to some real number k, 1 by x minus 5. So by replacing x as k over the function, we will get k minus 5. Here the limit is equal to the functional value. Okay, so we can say, which implies f of x equal to 1 by x minus 5 is continuous for any real number is not equal to k. Any real number k which is not equal to 5. So we have to check to prove f of x is continuous. We are taking k from real number where k is not equal to 5. Okay, because 5 is not a member of the domain of the function. So we can say the function is continuous for every real number which is not equal to 5. We will do the third subdivision. So this is third subdivision. Again, here we have to check the continuity of the function. So to check the continuity of the function, we will choose any real number. Let k be any real number not equal to minus 5. See, suppose if x is equal to minus 5 means we will get non-definite value. So they have defined the function in real numbers domain where the real number is not equal to minus 5. Now we will check the continuity. So we will calculate f of k. So before applying that, we are rewriting, okay, k square minus 25 divided by k minus 5, sorry, k plus 5. We can rewrite it as k plus 5 by a square minus b square identity. K minus 5 divided by k plus 5. So after simplifying this, we will get k minus 5, which is the functional value. Now we will calculate the limit of the function. Limit x tends to k, x square minus 25 divided by x plus 5. So before applying the limit, we will simplify this. We will remove the common factor. So limit x tends to k, x plus 5 into x minus 5, which is divided by x plus 5. So cancel the common factors. So we'll get limit x tends to k for the function x minus 5. Now after substituting limit, we'll get k minus 5. Here the functional value at k is equal to the limit of the function k min. Okay, so we can say the function is continuous. The function is continuous at k, where k is a real number belongs to R and k is not equal to 5. So we will discuss the fourth subdivision in detail in next video. Thank you.